guys, welcome back. So now today we're doing the prelim question of Gauteng 2023. So we're doing question 5 of paper 2. So question 5, that's where we get our trigonometry. This is where the trigonometry section of the paper starts. Okay, so now they've given us this diagram here. Okay, it says in the diagram below, P is the point, 12 and 5, and T is A and B. OT is perpendicular to OP, and PS is perpendicular to the x-axis, and POS is equal to theta. So everything that is in the statement is in our diagram, right? So now let's move on to the question, right? So now they want us to calculate without using a calculator and determine the value of tan theta, right? So tan theta, this is our theta. And remember, guys, we use this thing called SOHCAHTOA. SOHCAHTOA, right? And this is what we have here, right? We understand that our tan is equals to our opposite over the adjacent side, okay? So now let's go look here. What we have is this coordinate, right? And remember, this coordinate represents x value and a y value, right? But they want us to calculate tan theta, and we understand that tan theta is this opposite side over the adjacent side. But remember, we already have those sides. Let's show you how. Okay, so now remember, this is the origin. This is the same thing as 0 and 0, right? So what this means is that in order for us to get to point P, what we did is that we moved 12 units to the right, and we also moved 5 units up in order for us to get that coordinate of P. Okay, so P is x and y, right? Which means that we moved 12 units to the right. So which means that OS is equals to 12, and we moved 5 units up, which means that SP or PS is equals to 5 units. Okay, so now we have everything that we need, because we said that tan theta is equal to the opposite over the adjacent, right? So now let's go right. And so we have 5.1.1. We're looking for tan theta, which is equals to 5 over 12. So we sorted there. So now the next thing that we should look for is sine theta. Let's go back to our diagram, right? So in relation to theta, our opposite is that 5 that we have. But remember, when we come back to the SOHCAHTOA, its sine is equals to opposite over the hypotenuse, right? So we have the opposite, but we are lacking the hypotenuse. But okay, since this is a right angle triangle, we can go ahead and find the hypotenuse, right? By using the Pythagorean theorem, right? So now let's move. So we have 5.1.2, right? So now we know that r squared, which is the hypotenuse squared, is equal to x squared plus y squared. Okay, so r squared is our radius, right? Obviously, the way in which they view the Cartesian plane is like if we have a circle, or when we have a circle like this, right? And our center is 0 and 0, just for information's sake, right? It means that from this point to that point, this is a radius. So that's why it's denoted as r, right? So it's still the hypotenuse, it's just r, okay? Let's go. So our hypotenuse squared is equals to x squared, which we said is 12, right? Squared plus 5 squared here, right? So this is r squared. So it means that r is equals to the square root of 12 squared, I think it's 144, and then plus 5 squared is 25. Okay, so the square root of that r is equals to 13, right? So now our r is equals to 13. Let's go here. Our r, this is what, 13 here. Okay, so now that's what we have there. So we have our hypotenuse, we have our opposite. So now let's go ahead and calculate what they're looking for, right? So they say they're looking for sine theta. Okay, so sine theta is equals to the opposite over the hypotenuse, which is 5 over 13. Okay, so here we sorted with that one. So now let's move on to 5.1.3. So 5.1.3 asks us to calculate A if TO is equals to 19.5 units. Oh, okay. So now they're giving us a piece of information, right? So now what they're telling us is this length is equals to 19.5. But what they want is the x coordinate of t. Okay, so they want A. Right, so I don't know if you wondered now, or why did they give us this other 90-degree? Like, we could have done well with this one, but they've given us this other 90-degree, right? And we haven't used it yet. So that may be a clue on what to do next, right? So let's try and see if we can consider it as part of our solution for this question. So now let's move. So now what we have here, right, is this 19,5, okay? But they're looking for the x value of t, all right? Okay. So what it looks like now, let's just try and construct something here and create another right angle triangle, because we know that if we have a right angle triangle, we can either use our trigonometric functions or Pythagoras, which makes it easier for us to solve these questions. Okay, so now let's just try and join this line here, right? And obviously if I join it straight down, that is 90 degrees there. Okay, so now I notice that I have the hypotenuse of this triangle that I've just constructed here. Okay, so what I know is that the hypotenuse is the same thing as r, remember, right? And this side is x, okay, and this is y, okay. And remember, we are looking for this distance here, because that distance there represents the x coordinate of t, okay. So now if we had this guy here, we were sorted, but we don't have him. But is there any way we can use our trigonometric functions? Because we can see that Pythagoras is going to fail us because we only have one side, okay, which is the hypotenuse of that side. So is it okay if we can try by some way to find this angle here? As that if we can find this angle here, right, we can use a trig function, because we understand that this angle that we're looking for the side that we're looking for in relation to the angle that we have is adjacent, and we already given the hypotenuse. So adjacent over hypotenuse, that's cos. So we can use that. So our aim is to at least try and find that angle there. But okay, let's realize something further, is that we have theta, we are sorted. We also have a 90-degree angle over here, okay? But we are looking for this angle here. But if we can see something, is that all these angles, all three of them, lie on a straight line, right, which is our x-axis. So is it fair to say that this angle that we're looking for, right, plus this angle, which is 90 degrees, plus theta gives us 180 because of angles on a straight line? So that's fair, okay? So now let's try and move on, right? So just for the question's sake, let's name this point R, right? So that we can label our angle correctly, right? So we are going to go ahead and say this and do this, right? Angle TOR plus that 90 degrees that we're given, plus the theta that we're given, have to give us 180, because these are angles on a straight line. Okay, so now understanding that, we can therefore conclude that angle TOR is equal to 90 minus theta. Okay, so now that we have that angle, then now the rest is history. Let's resume and go and find our A, which is the x value of the triangle that we just constructed. Okay, so yeah, so let's move, right? So now let's go. So we are going to say cos, right, of that 90 minus theta, right, is equal to the adjacent. So if you go back to this, right, we just concluded that this is 90 minus theta. So we are saying that cos of this angle is adjacent, which is the A, which is the x value, right, of this t coordinate that we're looking for, right, is equals to A over our hypotenuse, which is OT, right? Remember, OT we've been given, so we are on our way to the answer. Okay, so let's go ahead. So now if we manipulate this further, we can see that, no man, this is a cofunction. Okay, so now let's just change that. This is going to symbolize sine theta, right, is equals to A over OT. So now can we make A subject of the formula? So A is equals to OT sine of theta. Right? So let's go ahead and solve, right? So it means that A is equals to OT, right? Remember OT is our 19,5, right? And sine theta looks familiar. It's 5 over root 13, right? Which we've already solved. So into 5 over, 13, yeah, not root 13, but 5 over 13. So we are sorted. So let me just punch this, right? So which means that A is 7,5, right? Or you could have written it as 15 over 2. So we are sorted. So with this question, we are sorted with 5.1, right? So now let me just resize everything. Then we can move on to the next question. I'll squeeze it in. It's NMO industry. Okay. So yeah, that's what we have there. So now let's bring this question forth. Okay. So now what we're looking at is 5.2, right? So now with 5.2, it says determine the value of the following without using a calculator. But of course, we can use a calculator, right, later on, right, just to confirm our answer, okay? But yeah, don't worry, we'll talk about that. So now the main thing that they check here is how you apply your reduction formulae, and if you know when to change cos into sine and sine into cos, right, whenever we have 90 and 270. But it's okay. Let's move on. Let's use yellow for this one. We're going to have sine 360 minus 2x, right? Remember, guys, we have our Cartesian plane like this, right? Obviously, this is, in this case, let's just use the x instead of theta. This is x, and then this is 180 minus x, and then this is 180 plus x, and then obviously this is 360 minus x. Okay, so this is what they call the cast diagram. So this is CAST, right? So what this stands for is the Chartered Accountants Salute Tapelo. Okay, so let's go. So now what we have to understand is that in the fourth quadrant, because we have a C, only cos is positive. And in the first quadrant, because we have an A, all of the ratios are positive. But in the second quadrant, only sine is positive, right? Only sine is positive. And in the third quadrant, only tan is positive. And then the rest are negative in those other quadrants, right? So in this case, we have 360 minus x, minus 2x, right? Don't buy in the 2x. It's the same thing, okay? So let's go. So now we're looking at it. It's in the fourth quadrant. Remember, fourth quadrant, only cos is positive. So we can therefore go ahead and say this is negative sine, right? Whatever angle that we have here. If we had 13, it was going to be negative sine 13. Now that we have 2x, we're going to put 2x just as it is, right? Multiplied by sine of negative x. So let's just think about it, guys. Let's just think about it. If this is x and it's positive x and it's the first quadrant, it means that if we go clockwise, this is just going to be negative x in the fourth quadrant, right? So it means that negative x belongs in the fourth quadrant, right? And again, the fourth quadrant, sine is negative, right? So what we are going to have is what we had there multiplied by negative sine x, okay? All over sine of 90 plus x, okay? So now 90 plus x belongs in the second quadrant, right? And sine is positive. But remember, 90, right, reminds us of a co-ratio. So whenever you see 90 with sine or with cos, right, you always change the ratio, right? So now that we had sine and we just declared that 90 plus x is in the second quadrant and sine is positive in that quadrant, our answer is going to be positive. So we're going to have positive, but instead of writing sine, we write cos x, right? So that's what we have there. And then let's furthermore, we have plus 2. And then now look at this. We have cos squared 180 plus x. Okay, so let's understand something. 180 plus x is in the second quadrant. In the third quadrant. And in the third quadrant, we've just said that 10 is positive. So since 10 is positive, it means that everything else is negative, which is sine and cos is negative. But remember here we have a cos. So how we write this is going to be what? We're going to have a negative cos x. But because it's squared, we multiply it by another negative cos x. Right? And yeah, the rest is history. Let's just simplify this. So now what we have there is negative sine 2x. Hey, man, this looks like something. It looks like an identity. So let's just change it in the meantime. Because at the end of the day, we're trying to simplify. So if we can change that, we can at least cancel it something with something and then find our way forward. So that is 2, right? Sine x multiplied by cos x. Okay? And there we have multiplied with negative sine x still. Okay? And then in the denominator, there's nothing we can do there, right? Which is just cos x. And then what we realize, it's plus 2 cos squared x. All right? Because it's cos x times cos x, and negative times a negative gives us a positive cos x, right? So don't be alarmed, right? We understand that this is 180 plus x, and 180 plus x is in the third quadrant, and 10 is the only thing that is positive in that quadrant. But because of this squared, anything squared, regardless of whether it's negative or positive, is going to give you a positive answer, right? So now that's why we have our cos as positive. So just keep that in mind. And remember, our aim is to simplify. Let's see if we can cancel some stuff out, right? So I see we're multiplying, so I can cancel that with that nicely, right? And let's further continue. I see that this negative multiplied by this negative will give me a positive. And I see that sine x multiplied by that sine x is going to give me sine squared x. So now we're going to have positive 2 sine squared x. Remember, we no more have a denominator because cos x has been cancelled out. Plus 2 cos squared x. Right, so now this is what we have here. And remember, our aim is to simplify. So we want to make sure that we get this in its simplest form ever. Right? And let's just read the question. So the question says, determine the value of, so when they say the value of, they want a number. So at the end of the day, we should not have any cos or sine in our answer. So we should just have a number, which is a value. Okay? So, we can see something here. I see sine squared x plus cos squared x. That's 1. But the problem is that this 2, as its coefficient, is disrupting us. So let's try and take that out as a common factor. 2 into sine squared x, plus cos squared x, right? This is equal to 2 into this is an identity, and that identity is equals to 1. Therefore, our answer is 2. Right? So remember in the beginning I said we can check our answer. Try this. Choose any number that you like. If you like, choose any number between 0 and 90. Right? So which means you can choose 1, 2, 3, 4, 5 until 89. Okay? Make sure that you be consistent with the number. So what you can do is just go on your calculator. Let's say x is 5. Né? You're going to put 5 here. Wherever x is, you put a 5. Wherever x is, you put a 5. And wherever x is, you put a 5. You can choose any number. If you choose 8, you put 8 wherever x is. And when you replace that into the calculator, it should give you 2. And then that's when you can know that your answer is correct before you move on to the next question. Otherwise, let's resume. All right. Furthermore, 5.3 gives us this question. All right. Okay. Cos 42 is equals to the square root of... Okay. Cos 42 is equals to the square root of k. Right. So let's try. First instinct, right, that comes to my mind, it's... let's try and see if we can use a diagram for this question. Okay. So obviously, we are going to have it like this. Right. And obviously, the angle that we have is going to have... so this is going to be 42. And because this is 42 angles, some angles in a triangle, this is obviously going to be 48. Okay? So now that we have that, we've been given that cos 42 is equals to the square root of k. And remember all from our soccer tour, cos is adjacent over the hypotenuse. So we can write this root of k into a ratio because we understand that cos is a ratio. So we can write this as square root of k over 1. So we haven't changed that it's square root of k. We've just changed it. We just put it in a different form. We've just put it in a form of a ratio because we understand that cos is a ratio and that ratio is adjacent over the hypotenuse. So now in relation to our angle, which is 42, our adjacent is the square root of k, right? Our hypotenuse in this case is going to be 1, right? And if we were to work this out, we were going to get that this other side using Pythagoras is going to be 1 minus k, I believe. Okay, so let's see. So this is my first instinct. So now they're looking for what? Sine 69. Hey man. Okay, sine 69 has nothing whatsoever to do with any of these angles, so we can't use this triangle that we've just constructed in this case, right? So let's just look at our next result. Mara no man, we have cos, but they want something to do with sine, and that angle has nothing to do with 42 and 48. So, okay, so let's just try and marinate this sine squared 69 and see something, man. Maybe we can find something. Let's just try and work with that and, try and simplify it to what we can at least find familiar with the information that we have. So now let's see. We have sine squared 69, right? Right. Wait a second. This is the exact thing as sine squared of 90 degrees minus minus 21 degrees, right? And the reason I think of 21, right, is because 21 is half of 42. So, man, we can do something. Double angle somewhere, somehow. We're getting closer to our answer, okay? So, right, let's move on. So now that we've written it in that form, remember co-ratios. Whenever we see a 90, we think of the co-ratios, okay? So now that we have that, this is the exact thing as cos squared of 21 degrees, all right? But remember, we have cos 42, right? So it's fine. Let's leave it here for this one. We have cos 42 degrees. And remember what we said. We said that we used 21 because 21 is half of 42. So now that let's try and apply the double angle here. We can rewrite this cos 42. Remember they said it's close to root of k. We can rewrite this thing as cos 2 times 21 degrees. Okay. Now that we have that, let's move on. So it's cos 2 into 21, right? Which is still equals to the square root of k. But no, man. Here we've just found out that cos squared 21 is something, right? Cos squared 21 is what we're looking for because it's equal to sine squared 69. And now we have a double angle of cos. So remember that double angle of cos has 3 identities. And one of the identities has something to do with cos squared. Okay, so is it fair for us to now change this? Okay, let's change this now into cos. Right, so there's this identity which is 2 cos. Right, so let me just write the identity here. So we know that cos 2 theta can either, right, be written as cos squared theta minus sine squared theta, or it can be written as 1 minus 2 sine squared theta, or more importantly to this question, it can be written as 2 cos squared theta minus 1. And remember, guys, what we're looking for is this guy over here. Okay, so now let's just change it into this one because it's most applicable, right? So let's resume now. So now we have 2 cos squared theta minus 1. But remember, guys, our theta in this case is 21 degrees. Helele. Okay? Which is still equals to the root of k. No, man. Let's try something. Remember, we're looking for this guy here. So we're trying to isolate that guy. So now to isolate that guy, let's just start by moving the 1 over. So this is 2 cos squared 21 degrees is equals to what? Root of k plus 1. So now, since we are looking for cos squared 21, let's divide both sides by 2. Now, we are going back. Let's try and use a different color. We're going back, right, to our cos squared 21 degrees. Right? So our cos squared 21 degrees is going to be equals to the root of k plus 1 all over 2. And then we are done. Remember, But we did prove that sine squared 69, I got 69 was equals to this very same cos squared 21 degrees. So it means they are all equals to the root of k plus 1 over 2. And then really we are done with this question. So yeah, that's a proper question. That's a beautiful question. But okay, let's move on. It's okay. It's okay. It's okay. It's fine. Right, so in this case, we are given 5.4 gives us the following. Given the identity wara, right, we need to prove this identity. So with the identities, guys, we always, right, just need to prove that the left-hand side is equal to the right-hand side or vice versa. And we always deal with the side that looks more complicated, right? So this side is the one that looks like there's a lot going on, okay? So now that we have that side here, let's try and marinate this side in order to make it look like that guy there. All right. So this takes, a good eye to see, or no, man, there's something wrong here. There's too much going on. There's just too much going on here. But if you realize we have sine, cos, sine, and then we have 5x. We have 5x this side as well. We have 3x. We also have 3x this side. And this reminds me, or should remind us, okay, of the double angle. Not the double angle, I meant the compound angle, right? So sine, right, of theta plus k, for example, if it is expanded, it is going to be equals to sine, cos, sine, okay? But of course, the sign is kept, so we're going to have a plus there, and then now we just fill in the angles. So now we're going to have theta here, and then we're going to have k. And then now we're going to have theta here, and then we're going to have k. So this thing that we see here is the same thing as the compound angle of sine expanded, right? So now let's try and rewrite that. So we're dealing with the left-hand side. So we've identified that left-hand side is the one that has a lot going on. So now the left-hand side is equals to that at the top there is the compound angle. So we can rewrite this as sine of 5x, right? This is a minus. So this is also going to be a minus the other angle, which is 3x. Oh, okay. Now we have a double angle. It's fine. Okay. All over 10x. Right. Remember, guys, 10x. Whenever you see 10, guys, let's just change it same time. Sine 2x. We keep the angle over cos 2x. Right. So this is a mark already. So if anything, this mark is a free mark. Okay. Right. Let's resume. So now what we have there. Okay, remember, hey, let's not forget it's -1 here, right? So now, the rest is history. So let's try and do the sine. This is going to be sine. 5 minus 3, this is 2x. So now we have a double angle. We have a double angle at the bottom. Get what I mean? We also have a okay. So now this is divided by, let's just write it like this. Sine 2x over cos 2x. Right? So the aim, right, is to simplify, right? We can see that we have double angles, right? But before we even change these double angles, let's see if you can marinate it further. All right, so we have -1 there. Let's not forget that. So this is the exact same thing as sine 2x multiplied by tip and times cos squared x, cos 2x, I meant to say, over sine 2x, right? And what we're going to have here, this is going to cancel that out. All right, so now we have something now. Right, so now we have, this is the same thing as cos, hey, let's not forget the -1, hey, cos 2x -1. And where we're trying to get at, okay, is this guy here. So remember, guys, we have a double angle of cos. It has 3 identities, but we need to substitute one which is most appropriate for the question. And we can see on the right, we have what? Sine squared x. And remember, amongst our identities of cos, we have this one. And God, they like it. We have this one. Okay. So now that we have this one, we can put that one because it's most appropriate to the question. Is the one that's going to make the left-hand side equal to the right-hand side. Right? So let's resume. Okay. So now this is the same thing as 1 minus 2 sine squared x. -1 outside there. Obviously now there's going to be 1 minus 1 minus 2 sine squared x minus 1, and obviously these two are going to cancel out. 1 minus 1 is 0. Okay, so it means that this is the exact same thing as negative 2 sine squared x, right? So this is our left hand side, and we've proven it. So therefore our LHS is equal to the RHS, right? So RHS, which is that one there. So we are sorted. So we've proven the identity. Now let's move on to 5.4.2. Right, now they say that determine the values of x for which the identity will be undefined in that interval. Okay, so now let's understand something. Undefined means non-real. Non-real means undefined. When you put on your calculator, it's going to give you a math error. So that's what they're asking us. And one of the characteristics of something that is undefined is if we firstly divide by 0. Okay, so that's our first thing. We're going to equate our 10x to 0. Okay, so we're going to equate our 10x to 0. And also, whenever you see 10, always, whenever they ask you for something that's undefined, as long as you see 10, right, your first resort is to always be equating your angle to the asymptotes, because you understand that 10 is also undefined at specific points, right? 10 has asymptotes, has points that it never touches, right? So that's the first thing that we go. Let's just get the obvious mark first, okay? So now, let me just minimize this. Let's just minimize, okay? So that we can have some space. So let's just minimize that, right? And then now we are at 5.4.2, okay? So the first thing is just to say that equate it to the asymptote, same time. 2, we had 10 2x, right? So as long as we have a 10, we just take it as it is. 10 2x is equals to 90 degrees plus k 180, where k is an element of integers, right? So where k is an element of integer, right? So now that's the first thing that we have. But remember, guys, we're not looking for GS. They don't want the general solution. I think this question was even 2 marks, right? But let's just do it the long way, just for understanding purposes. Okay, so this is what we have here. So it means that x, divide everything by 2, is equals to 45 degrees plus k 90, right? Where k is an element of z, right? So now this is what we have there. All right, now understanding that they want the value of x, not the general solution. So it means that we need to substitute k, right? Substitute k with what? Integers. So k cannot be 0.5 in no ways, because we said k is an element of integers. So it means that k has to be 1, 2, 3, 4, -5, -18, whatever, right? But we need to replace it in order to get a value of x. But our value of x is only restricted to this interval, which is 0 to 60, right? So now if we replace here, I notice that if you replace 0 with k, we're going to get our x as 45 degrees, right? If we try and replace this with 1, we are going to get 135, but it's out of our interval. If we replace it with -1, we're going to get -45, which is out of our interval still. So this is the first solution that we get from here. But remember, we also said something is undefined if, right, if the denominator is equal to 0. So let's go ahead. 10, right, of 2x has to be equal to 0 in order for us to have that thing as undefined, because that's the denominator, right, of that expression that we have there. Righty. So it means that if we were to find our reference angle, we're going to get that our reference angle is 0 degrees, right? So remember that tan is positive in the first quadrant and the third quadrant, okay? So now what we can do now is just to say, yeah, let's just do this. Let's say 2x. So this is the Q1, right? So now this could be done like same time, just by inspection, because the question is just 2 marks, but we're just doing it the long way for understanding purposes. Okay, so the 2x is equals to 0 degrees plus k 180, because this is tan, with k is an element of an integer, is an element of integers, right? So in this case, what we can realize is that if we replace, hey man, let's wait a second. We haven't divided. So x is equals to 0 divided by 2 is still 0. So still 0 degrees plus k 90, where k is an element of integers. So now in this case, what we can realize is that if we replace k, remember we're looking for the value of x, so we need to replace k with an integer. If we replace k with 0, we are going to get that our what? Our x is equals to 0 degrees, right? And which is part of our interval there. So we could further go on and calculate for the third quadrant, but it's still going to give you the same thing, right? And yeah, so those are only two x values. So we understand that if we were to rewrite this thing here, this expression here as we have it here, the whole thing, and replace x with 45, wherever x is we put 45, we are going to surely get something that's a math error on our calculator. And if we replace x again with 0, we're going to get something that's a math error on our calculator. Then yeah, that's what the question was that's what the question was asking for. And then yeah, we have our marks there. Let's move on to the last part of question 5, right? So 5.5, it says given that f of x is equals to 2 cos x minus sine squared x. Then it says for 2 marks, just for 2 marks. 5.5.1, show that f of x can be expressed as that. So hey man, this thing looks like they completed the square. It gives me turning point vibes. All right. But other than that, let's see what we can do. Okay. So now let's understand something first of all. This 2 cos squared. Okay. I want to see something. Right. So look, the thing that we need to write it as only as cos, and here we have a sine, and we can see that that sine squared x can be changed. So let's start there. So f of x is equals to, right, 2. Let's start by changing that, because we can see that what we're trying to get to is cos only, matter we have a sine, so it's disturbing us, right? We need some distance. Okay, so we need space. So cos x minus, right, 1 minus sine squared x, right? So that's what we have there. Okay, so now let's resume and continue to marinate this. Cos x minus 1 plus negative and a negative sine squared x. Okay, so let's just rewrite. Hey, why am I still having sine squared x? Oh, what? Right, okay, made a mistake. Okay, sorry about that. This sine squared x, okay, can be written as 1 minus cos squared x. Remember the identity, the square identity. Okay, so this is going to be minus 1 plus cos squared x. So now let's rewrite this in standard form, nyan. So it looks like something. Cos squared x plus 2 cos x minus 1. Okay, so now we have it in standard form like that. But remember, they want it in this form. So like we said, remember we said this form looks like it gives us, completed the square, vibes. So let's try and complete the square here. All right. So completing the square is this is how you approach it. Okay, you can just say cos squared x here, right? You rewrite the thing as we have it, plus 2 cos x, right? And then now we're gonna do something. I'm gonna use a different color for this, because we are marinating. We're not actually changing the expression, but we're marinating it. So what we do is we're always gonna have to get our formula first of all into this form: a x squared plus b x plus c, right? So obviously in this case, our a, right, in this case is going to be 1. Our x is acting as our cos x, right? So this is how it's written. So now this is why we always want to get it in this form, in this way, right? And let's resume. I want to write this in a different color. Okay, we rewrite this, the first 2 as they are, and then we're going to take the coefficient of b, right, and divide it by 2 and square it. So 2 divided by 2, so we're going to add plus 2 over 2. The coefficient of b, we square it, right? But we plus it there. and then we are going to minus it again, the exact same thing. Squared, and then remember we still have this minus 1 yet. It hasn't gone anywhere, minus 1. So if you can realize, right, is that what we've done here is nothing actually. It's just like saying plus 1 minus 1, right? But the main aim of doing this is to write it in a different form. What you'll realize here is that now we have something beautiful here. We have something here. We have something that we can factorize, right? So the factor of that, the factorization of this is just going to be what? Right? So this is, so remember this thing is the same thing as 1 when it's simplified. So we're going to have this. I have 2 brackets there. We're going to have cos x, and then we're going to have another cos x here, right? So we have to find the factors of this one that gives us that 1. So you're just going to find that this is 1, and this is also plus 1, right? But remember here, we still have this thing on the other side. So this is the same thing as minus 1 there, okay? So now this is the exact same thing as cos x plus 1 all squared, because it's the same thing multiplied by itself minus 2, which is how they wanted us to write it. I fail. So now let's move on to the last question. It says, hence or otherwise, find the maximum value of f, right? So f of x is that, right? And we've just simplified it, okay, to this. So now, okay, it's okay. So now that we've simplified it to that, let's try and work with what we have, right? So it says hence or otherwise. When it says hence, you can use this previous answer. Now it's saying otherwise. It means you can also work straight from the scratch, right? So you have 2 options there, right? So we can use the answer that we got or what we have in the previous question to get the next one, or we can start afresh. I'm just going to use what we have, okay? Because at the end of the day, it's 2 marks. I don't want to waste time. So now what we have there, now they want the maximum value of f. Maximum value of f. But we can see that f is this cos x plus 1 squared whatever. So our aim, right? So since they're looking for the maximum value, we are going to write everything here that we have here in terms of maximum. I don't know if you get me. So we are going to find the maximum value of cos and then replace it there, and then we move away. Okay, so there are types of questions. There are questions like that where it says determine the maximum value of, but it's fine. So just for understanding's sake, let's draw our graph here. Let's use this light color. Okay, so we're going to have, let's just use this first. We're going to draw cos x because we have cos x on our equation, cos x. Remember, guys, that cos x is the mother graph. The mother graph, which means that it has an amplitude of 1. It's negative 1. So if we were to draw the graph, it's going to look, I've been using red for long. Let's use something pink in yana, to accommodate the other gender. Okay, so it looks something like this. Cos, the mother graph is like this. So when you know the mother graph, you're sorted. So this is what we have here. So now we know that our maximum value, so the max value, so let's just write max value of cos x is equals to 1. Okay, so now therefore that we have the maximum value of cos x, we just replace 1 wherever cos x is because they want the maximum value. So we are going to express f of x into its maximum value depending on what ratio that we have. So now we found the maximum value. So remember they said f of x is equals to cos squared x plus 1. No. It's not like this. It's cos x plus 1 squared, right? Minus 2. So now that we found that this maximum value is 1, we're just going to replace it like that. So this is how these type of questions work. Okay, we can just square that minus this, which gives us a value of 2. Because it's 1 plus 1 is 2. 2 squared is 4. 4 minus 2 is 2. And then, yeah, we are done. And that's how the cookie crumbles. Okay, so this is what we have here. So this was question 5 of the 2023 prelim of Gauteng. Okay, and yeah,